All right, the new notes for today. We're going to first start by reminding you the definition of parallel, so that, or at least what we care about being parallel. And then we'll do a little bit with that, and then we'll look at perpendicular lines, talk about some slope relationships there, and finish off. Parallel lines, just a reminder, we said in the warm-up that parallel lines are, two lines are parallel, if they have equal slopes. Yes. The two main goals for today, we're going to write equations of lines that have relationships to other lines. We'll start with parallel, because we've already done a little bit with parallel. We're going to write an equation of a line that passes through this point and is parallel to a given line. So, say in our first example here, we want to write an equation that goes through this point and is parallel to this line. Well, if we want to write the equation of a line, we said we need two things. We need a slope and a point. What's a point that's on the line we want to write? Negative 2, 11 is definitely on the line we want to write the equation of. Now we need to know what the slope of this line is going to be. Well, how does our line relate to the line that's given? Okay, it's parallel. So what's that tell us about their slopes? They're the same. Okay, so what should our line's slope be? It's the slope of this line, which happens to be negative 1. All right, now we just got to do what we did last trimester, which is write the equation of a line that has these parts. See, one way we did it was using mx plus b. And recalling, if I know a point and I know a slope, I know x, y, and m, and I'm going to try to find b. So I could say, how about if I plug in all that stuff I know? Y is 11. M is negative 1. X is negative 2. And I don't know b, but I'm going to try to find it. What's negative 1 times negative 2? Positive 2. Negative times a negative is positive. 1 times 2 is 2. 11 equals 2 plus b. What's b equal to? 9. Okay. So then what's the equation of my line that's parallel to this one and goes to this point? Using the slope, using the y-intercept, I plug them in and get negative 1 times x, or negative x plus 9. All right. Let's see if we can try this again.
Okay. Can we do it the other way? Can we do it in point slope form?
If you want to do point slope form, sure, but we're gonna your final answer, I want to see it in slope intercept form. I want to see it in that. So we can write it in point slope form, but then I want you to rearrange it so it's in slope intercept form. We can do that. That's not so bad. So same game. I want to find a line parallel to this one and through this point. So let's see, we have a point. That's definitely negative 3, 3. What's the slope of our line that we want to write the equation of? It's parallel to this one. So what do the slopes of parallel lines look like? So then what's the slope of this line? Negative 2. So then what's the slope of the line that we want to write? There we go. Okay. You can do the same thing we just did here. Or you could use point slope form, but in the end I want you to rearrange it so it's in y-intercept form. So if you did it in point slope form, it looks something like this. We go, the equation for point slope form was y minus y1 equals m times x minus x1. So let's see. This is the y from the point, the slope, and the x from the point, which is -3, minus a negative plus a positive. So if I'm going to simplify this into slope-intercept formula, y equals, let's distribute this -2. -2 times +3 is -6. You can do plus -6 if you want. Add 3. And end up with this, just by distributive property going in. This again was in point slope form. If you didn't want to do that and you want to do slope-intercept form, what we just did on this side, I did it last hour, and this is what your work would look like if you did that. Notice -2x minus 3, -2x minus 3, you get the same equation. So let's answer this comparison question. How are parallel lines different? We've already said they're the same. Or what's the same about them is they have the equal slopes. So what's different about parallel lines? Sarah? Okay, y are different. Okay. So this is a kind of important follow-up question. Is that what if you have two lines with different y-intercepts? Are they necessarily parallel? Not always. What should be true if the lines are parallel? They do need to have the same slope. Okay, before we move on to the back side, let's jot down the relationship of perpendicular lines. We get to go. Okay, so perpendicular lines. We said parallel lines have equal slopes. Perpendicular have the following relationship. Two lines are perpendicular if they have opposite reciprocal slopes. Perpendicular lines have this relationship. Their slopes are what are called opposite reciprocals. Oh boy. What's a reciprocal? How do I know a reciprocal of a number? How do I get a reciprocal of a number, Lily?
It's like when fractions, like when you're dividing two fractions, times the guy and multiply.
Okay, so yeah, the flip the second guy part is a reciprocal. So if I want to find the opposite reciprocal of a number, here's a given number, 2/3. What's its opposite reciprocal? Well, what's its reciprocal? Okay, we flip it. Opposite means change the sign. So if this first one started positive, then we'll make the opposite reciprocal negative. Okay. If 5/4 is my original number, what's its opposite reciprocal? Okay.
So what if I say like a number 2? Would it be -2? Or would it be 1?
What's the opposite reciprocal of the whole number 2? Dana?
So you have to flip it and change the sign?
How about you write the whole number as over 1? What do I get? How about this guy? We'll do one last one. Sure. What if it starts negative? What would be the opposite reciprocal of this crazy fraction I just made up? Change the sign, opposite sign, and flip it. So positive 11/6. Sure. Okay. That's what I mean by opposite reciprocals. So if the slopes fit this pattern, then we know they're perpendicular. Okay, it's just another pattern to look for. Opposite reciprocals. Okay. Well, to determine which lines, if any, are parallel. The symbol for parallel are two lines that look parallel to each other. The symbol for perpendicular says perpendicular lines intersect at right angles. Is these two lines intersecting at right angles? It's like an upside down T. Okay. Sure. Determine which lines, if any, are parallel or perpendicular. How are we going to do that? What do you need to find in the equation? Let's find the slopes and then compare them. What's the easiest way to find the slopes of these lines? All the things we just did in the warm-up. Yeah. So we'll do the first one together, and then we'll let you guys work on the second one. Let's rewrite each of these three lines in y equals mx plus b form. When we do that, we can just compare the slopes. So let's start with this first guy. I want to write this in. I want to write the line A here in y equals mx plus b form. So I could say, how about I subtract 2x and get 6y equals negative 2x minus 3. Divide both sides by 6. And you get this equation. Y equals negative 2 over 6 is the same as negative 1 over 3. And negative 3 over 6 is the same as negative 1 over 2. So what's the slope of this line? That's all I really care about. Negative 1/3. How about line B? I need to write an mx plus b form. Hey, it's already there. What's the slope of this line? Just 3. This guy's got decimals. Wahoo.
Stupid guy.
Whatever, decimals are just numbers. Negative 1.5y. Still the same thing. Subtract 4.5x. Divide both sides by what's in front of y. And I get y, get positive 3, and I get negative 4. You use a calculator to check your answers, but you get that. What's the slope of our line C here? Okay. So, what are the parallel lines? Do we have any? B and C are most definitely parallel. They have the same slope. Do we have any perpendicular lines?
Yes.
Okay, what's a pair of perpendicular lines that we have? A and C. Notice that if you wrote these as like 3 over 1, you get flip and change the sign. So A and C are most certainly perpendicular. Do we have any other pairs? A and B are also most certainly perpendicular. Okay. I'd like you to, either on your own or with the person sitting next to you, please do the exact same thing for the second example here. Tell me which pairs, if any, are parallel, perpendicular, or So we're going to write an equation of a line that passes through this point, but this time is perpendicular to the given line. Well, the question's almost identical, so what we do is probably also going to be nearly identical. We still need to figure out what the slope of the line we want to write the equation of is. But we still want to get a point that's on our line. Well, one of those two things is pretty evident. What's a point that's going to be on the line we're going to write an equation of? We're definitely going to use the point 4, 3. We need to find the slope of this line, though. Well, how does this line and our line compare to each other? They are perpendicular. Well, how do perpendicular lines compare? They have opposite reciprocal slopes. So what's the slope of this line? What's the slope of this line? What should the slope of our line be?
-1/2.
Sure, -1/2 or -1/2. So our line that's perpendicular to this one has a slope not of 2, but of -1/2. Oh boy. Now that you know the slope and you know a point, everything else is identical to what we just did. It's the same thing. Same darn thing. Y equals mx plus b. M is -1/2. X is 4. Y is 3. We don't know b. What's -1/2 times 4? Multiply comes first. How do we multiply a fraction to a whole number? Put over 1 and multiply straight across. Okay, so what's b equal? Okay, so then what's the slope of our perpendicular line here? Slope, y-intercept, write the equation of your line. Y equals -1/2 of x plus 5. Let's try it one more time for good measure. We'll call it good for today. Okay, we need a point. We need a slope. What's a point on this line that we're going to write the equation of? Okay, easy one. What's the slope of the line that we want to write the equation of? This slope, opposite reciprocal. Okay? So we want what? -2 equals 1/4 times 4 plus b. What's b equal? So what's our line's equation? How about that?